So some of you might have already known this, but I actually have my background in chemistry and not in computer science or programming. So I thought it would make sense if my contribution to free software and the open source world would be something related to chemistry. So I've been working on this program which I named Nice Molecules, and you can find it on my GitHub. So if you go to my GitHub page, there you will find Nice Molecules right over here. In my repositories you will find Nice Molecules at the top here, and you can start helping me out with this project because as you might have noticed, the user interface and the UX part is not really my forte. I haven't really been working on this project for that long. I didn't do that much yet, but my main goal is here to make a chemical formula drawing program which is chemically sound. So whatever you draw here should be like a valid molecule. So you can see that I draw this very simple carbon chain here. I can add an oxygen atom here, or maybe I can add an oxygen atom with a double bond here. But if I want to add something else to this carbon, I cannot do this because the carbon has only 4 valence electrons and all of them are already taken up by these bonds. And I can add the hydrogen to this oxygen, for example, but I cannot add to this one because oxygen has only 2 valence bonds. And so if I can have, for example, the sulfur has 2 valence bonds, but the sulfur is in the 3rd row of the periodic table. So some elements like fluorine can have more connections here, but I cannot add any more over there. And I accidentally added one fluorine over there. So let me just select this and delete. So I can already delete and modify atoms. So if I want to change this carbon to a phosphorus, I can do that. If I want to change this sulfur to phosphorus, I cannot do that because the phosphorus could not have that many fluorine atoms over there. So now I can. Now it's only 5, so now I can. And similarly, if I want to add oxygen, and for example, I set my bond order to 3, so you can see here it's not really user-friendly. But if I add atom here, add an oxygen, and I want to add another oxygen with triple bond, I cannot do that, but I can add with the double bond. Whatever happens when I want to add a carbon monoxide, for example, I have the carbon atom, and the carbon monoxide case, we have an oxygen with a triple bond. But actually, that's not just a simple triple bond because in that case, the oxygen will donate an extra electron to this bond. So I press this arrow here to make a coordinative bond. And now you can see there is this little arrow on one of the bond signs here, which shows that this is a coordinative bond. So we can do all these things. And if I want to add carbon atoms that can, that's something that actually chemically makes sense, even though it's not really something that you would see often. So you have to switch back to the regular bond here, and I switch to hydrogen and single bond. So you can see that this carbon has lost its additional electron by donating it here, and this carbon here has a full shell now because this carbon donated 2 electrons there. So let's just change this to a normal regular bond instead of a coordinative one. So I selected this after clicking the select button and press this one, and now it's a regular triple bond. So now if I want to add additional hydrogen atoms, I can do that. And I can also connect existing atoms. So for example, if I draw something like, I don't know, I want to have a cyclopentane, for example, then I might want to just connect these 2 atoms here. And every possible connection that you could make and chemically would make sense, even though if it's really long, it will appear here and you can add if you want to, or if you want to, you can just select and delete. So these are kind of the functions of this program at the moment. And I wanted to just give you a very brief tour of the source code. So if you are interested in this project, or if you are interested in chemistry, or you want to contribute to a free software project that is in the field of chemistry, then, this is where you should help me out. And so I will give you a very quick tour of the source code. And, if you know someone who might be interested, you should tell them, of course, about this project. So let me go back to my terminal here. And if I list all the files in this directory, you can see that we have 4 Python files here. One of them is just for testing. So it's actually 3 files that I'm working with. One is this element.py that is just contains this abstract class for the elements. So everything we want to add about an element is in this class. So in this case, we only want to know the symbol, how many valence electrons it has, and how many electrons it can have on its valence electron or its valence orbitals. So, for example, most of the atoms will have 8 to have a full shell. And some of the atoms, as I showed with the sulfur and the phosphorus, for example, which are in the 3rd row of the periodic table or lower, they can have more than a full shell worth of electrons around them. So these are kind of the 4 attributes that each element will have in this state, and we can add more later. So, for example, we could add atomic masses. So later we can get these atomic masses from here and add them together to calculate molecular masses and things like that. So here I also have the classes which inherit this element, and each of these elements that I added to this program has a class here. So hydrogen has the letter H as a symbol, has 1 valence electron and 2 electrons fill up the shell, while boron has the letter B and has 3 electrons. And because 8 is the default number for the full shell, I did not have to specify it here. And the silicon, phosphorus, and sulfur has all the hypervalent set to true. And I also made this list here, which just contains an instance of each of these classes. And I have the instance for these classes, so I can use these properties, and through these properties, I can enforce that these attributes, like the hypervalence or the full shell or the number of valence electrons or the symbol, cannot be modified later. So that's the first file. I have the molecular engine, which this basically has 2 classes that we have to mention. This one is just some error types. So the covalent bond class, which will represent each of the bonds between atoms, and the atom class which will represent the atoms themselves. And so if I go to the constructor here, we can see that, or I can just hide this, that each atom will have an element attached to it. And this is, so because this element class, the element singletons, it basically uses singletons because just each element only has to have 1 instance, and we just, for each atom that will appear on our screen, we just link 1 element to them, because once we have this element there, we can use these properties here. For example, if I want to get the valence electron number, that will just return the valence electron, well, minus the charge, of course, but we don't care. I didn't really implement the charged atoms or ions rather in the graphical user interface yet, but basically this will get the valence electron number from the element that is linked to this instance. And this way we can use all these different properties to gather information, or let the user gather information. So this basically, what I want to do here is to have this this atom class and this covalent bond class to be useful not just inside this specific program I'm working on, but someone could just grab this engine here and use these atom and covalent bond classes in their own chemical application. So I want it to be useful kind of as just a package, just kind of, a Python package if you want to deal with atoms and molecules. And so we have all these setter and getter functions here. So, for example, if you want to get the charge of the of this atom, you can just reference the charge variable, but whenever you reference this charge variable, this is a property, so you will either use this get charge to give you what is the charge currently, or if you want to modify this charge, it will use the set charge function, and these set functions will be able to do a check whether this change in the charge would make sense. So this will take into consideration what other atoms this atom is bonded to, and if this changed charge would make the bonding of any of the atoms nonsensical from a chemical point of view, it will just give us an error. And similarly, if you want to change the bonding situation, that will be similar in the bond class. It also has, so the covalent bond class also has all these getter functions that will give you information on the bond, and you can, for example, change the dativity and whether it's in the coordinative bond, and they will use this set dativity, and similarly will make the checks that are needed, so we can always make sure that whatever we represent here with these classes, those will have chemically meaningful things. So these will be chemically meaningful, and for example, the electron count you cannot change directly, so we'll just use the toss function as a setter function, which will just raise an error that you cannot modify this attribute. And the last file we have is the mol GUI here, which is the most complicated one. So I wrote this in Tkinter, and using these TTK widgets, which are a little nicer looking, but it's more, it's strange to customize them, so that's why I don't really have a more sophisticated user interface, because I basically just use very simple TTK button commands here. So if you know Tkinter and would like to help me with this, then please do so. Please fork the project on GitHub and contribute. So here, basically, the app container class, it just inherits a Tkinter window, and that window contains all the other things except for the top toolbar, which I added into a different class just to make things a little more separated out, because it's already a very big class, this app container. And so it contains all the functions related to drawing the atoms and creating new atoms, connecting new atoms. So everything is just done here, and I use a canvas for the white area, which you can see. The drawing board is a canvas. Where is the canvas? Here it's a molecule canvas. So we can add lines and text and arrows to this canvas, which makes it very easy to create the drawings there. Well, not that easy, because you can see it's a lot of lines of code around here that we have. So yeah, I guess this is the end of this video. This is the project. So if you are interested in nice molecules, you can find me on GitHub with this. Please help me. And now it doesn't have a license, but by the time you will see this video, there will be a license added here, so you know under what terms you are contributing. So thank you for watching, and if you are interested in other of my projects, of course, check out the GitHub. You can always talk to me on one of my social media accounts, like you can find me on Mastodon, but not on DistroToot. I'm not on DistroToot anymore. Just check out my new Mastodon instance down there. And if you have any questions, leave them in the comments. Subscribe for more content, and I will see you next time. Bye.